Okay, I'm talking right now. Am I being heard? All right. So this is enough? This is not? Okay, good.
This is it.
All right. Do we start? Yeah, okay, I'll wait for a minute. It works? Can I try it? Yes. Okay, perfect. I'll just leave it here. Cool. Oh, yeah, interesting. And very smart. All right. Do I start? Or do we wait for Andy? All right. How long do I have? 10 minutes? 15, 20? 10? 10 is okay, I think.
For the presentation?
Yeah.
I don't know the schedule, so I have to ask Rennie.
Okay, when he comes, I'll ask him. It can go in 5 minutes or 10, whatever.
I guess that
Or 15.
5, 10, 15, 20 is all fine.
Let's leave some for questions, and I'll try to go for 10. I'll go for 10. 10.
Welcome again, everyone. We are going to start again.
It's a game.
A game from scratch.
With scratch.
With the first talk from Alexander.
All right. Hi, I'm Alex from a company called GameChuck, and we're moving to Godot, as it says here. All right. This is the yeah. That's it. Thank you. Thank you. All right. That's it. Thank you. All right. So I'm going to talk a bit about the company, but just a short while. So we made our first game as a company in July 2017. It was called All You Can Eat. It got a lot of awards and recognition. It's available on Steam. Before that, I was working in another company, but just like an employee, and we made a lot of games. This is maybe the most famous one, like Victor. It's also on Steam. It's a point-and-click adventure. The latest game we made in this company that we have right now is Vape Escape. It was out on Humble Bundle in November. It's going to be out now on Steam soon. So and it was like a Humble original, so it's a cool thing. And now we got some investments and so on. So we have the next project, which is going to be a bit bigger, which is on the slide after this one. We're also making a I'll show it. Okay, this one. This is Trip the Ark Fantastic.
Nice one.
Thanks. So this game is going to take a bit longer to develop, so it's a longer period. And for this game, actually, we're transitioning to Godot language, okay, which is the topic of the whole lecture, because I'll explain why and what is bugging us and why we're transitioning so on. But just for the last slide that I skipped, when we're also making arcade games and arcade machines. So this is our machine actually that we built. We have a CNC cutter in our office, and we cut this stuff ourselves and put the our Arduino inside, and our games are playable in various cafes in Croatia. We're from Croatia, yeah. And this game that you can see here, it's actually available on Google Play as well since February. Okay, so whatever. Enough about the company. So this, so we for all the games before, we used the Game Maker Studio. Game Maker Studio was like it's a proprietary engine. We use it because it's very good for 2D stuff. You can prototype real quick. When we need to like export to Android, it costs like $100 once, and then we're done, which is not that big of a deal. it's a very simple language. The community is large, and they have a lot of plugins for like AdMob or whatever you need, Steam and so on. So we use that until like now, and we're using it for the current game. But for our next project, which is starting now, we're not. Why? Because in August 2018, GameMaker Studio was the support for it was dropped because the company transitions to GameMaker Studio 2, and we had to move to it because we got a new employee, and she was a programmer and she couldn't download the the first edition of the language, the engine anymore, because they put it down from the internet, and so we all had to, like, as a company, migrate to another engine which isn't very well documented like the last one, and it has a lot of IDE issues. And if I had my laptop connected, I would show you, but it's just like it's not in a good state right now. And of course, there are financial issues, so we paid for all the exports, and now we have to pay for them all again because this is the company policy. Like, it's a new engine, it's called GameMaker 2, so now you have to buy it all over again. So we said, nah. We said, okay, let's find something that's not gonna do this to us every couple of years. And so we found this engine called Godot. And the investors who are investing in this upcoming project, the games, it was really interesting to them because open source is always like long-term, more sustainable, and sounds good. The community seems great. I asked some questions on Discord, and I was like, there were some trolls, but there were also very professional people who explained stuff really quickly, so that's great. And it has great potential, you know, it's very, very fastly growing and so on. And the roadmap is very transparent, so I can see if something is missing that I think is very important. I can see, okay, so it's here down the road, sometime in Godot 4 it's going to be implemented, that's important, and so on. So all of these things are good. The next slide is about the testing of performance. So when you have like a company which is like small or medium sized or big, it doesn't matter. Ours is, let's say, small. It's still like a big thing to like migrate your entire company to another engine without at least trying to like figure out whether it's gonna work. So we tried to make a little bit of performance testing to see if it's viable, you know, if it's not going to be problematic for some reason, you know. So we made two tests. One was for CPU and one was for GPU. I'll just skim through the tests quickly. We made them in Godot 3.1, beta 3, if that means something to someone, all right? And we made them in the both versions of our previously used language, the GameMaker Studio, and also in Unity, the newest Unity branch, yeah. Not the newest, but quite new. We didn't do it for Unreal because all of our games are 2D and are going to be 2D for quite some time, so we just skipped Unreal for this testing. Okay, so the first test was, okay, the tests were made on a lot of computers by employees, friends, and so on, but this is my computer, so laptop actually. Just to figure out, when you get the numbers, it's for something like this. This is something like a normal gaming computer for some gamer out there who would play our games, I guess. All right. So the first test is the instance spawning. So we wanted to check if like CPU would. Okay, this is a bit to the left, but I'll read it. Don't worry. So we have made two objects. The black one is the spawner object. Each frame it creates like a lot of bullet objects, and the red ones are obviously bullet objects. And all they do is just move in some direction at some speed, random, and rotate slowly. The point is to see when the project would freeze, after how many instances, you know, for which engine. So these are the results, you know. So the old GameMaker Studio is really close to the metal. It's really connected to the CPU, so it has like 20,000 instances. But if you can see, like their new bad version is like 6,000 instances, so like more than 10 times worse. Godot is around 7,000 instances. Unity is pretty good at 15,000. So this is something that maybe should worry some people who are making something like bullet hell games, you know, games with a lot of instances at the same time. It probably won't affect us because we're making story-driven, single-player, adventure, role-playing games, so it's not a problem, probably. But it's something to keep in mind, and to think about. And the second test was more GPU-based, maybe more interesting to us. So we took the assets from Victor, the game I used before, and we dumped a lot of them on the screen, like 30 different animations, largish ones, 50 small pictures, and 5 big backgrounds on the screen in different engines. And we checked the GPU, how much of the GPU was used and how much was left free. I'll check the results right now. So the FPS, this is not like the frames per second, like 60 frames per second kept. We just let it run at any kind of frames that it can go. If the CPU can run at 2000 frames, we let it run to see what happens. So for Unity we couldn't do it for some reason, but as you can see, it's 300 FPS average, which is still a lot over 60 FPS. But our previous language was quite better at this, like 10 times almost. So this is something that might be a problem, and we figured out why it's a problem. I think it's because of the graphics, how the graphic processor takes the sprites. It doesn't batch them into Atlas, it just sends them one by one, which might be a problem, but then again, it soon won't be when Godot transitions to Vulkan and so on. But it's something that we wanted to test before switching over. And also it's interesting to see how much percent of the GPU is actually used during this. So it uses a lot of GPU, which isn't confusing, because if it has to make 100 calls to the GPU for every sprite that it draws, of course it's going to overclock it a bit. Not overclock it, but use a lot of percentage, and okay, so this is just real data that we used across very different computers. Some computers had this issue that they didn't have, older computers, older laptops and so on, with integrated graphic cards. They couldn't play the Godot games because Godot engine now uses OpenGL 2 or 3. And for example, this laptop was OpenGL 1.1. So this is really old, yeah. Okay, so this is something to keep in mind, but there's some statistics for gamers, and not a lot of gamers use such old software and hardware, so okay, it's not that big of a deal. But these are all things that you have to consider when you're a company and you have to migrate. Okay, so we're gonna lose some people from Kazakhstan who are still on this laptop, all right? So these are our conclusions. So our potential problems might be if someone has an older configuration, we would have to optimize for it in some situations. Probably not for our games, but maybe in some more action-packed games. We might get some lower FPS, some drops at certain situations in the game regarding CPU or GPU. And certain Atlas management stuff that we could tool ourselves because it's open source and we could do it ourselves, but we would have to do it sometimes because otherwise some worse graphic cards would not be able to handle a lot of sprites on the same screen. So these are our conclusions that are really worrying us. And these are the solutions that we think are parts of this. So one solution is, of course, not use GD script, use GD native, okay? It's not really optimizing, but using code smarter, making smarter node management. So when you know, or you can think that this might be a problem, because there's a lot of sprites or there's a lot of action going on, just code it a little bit more smarter. And we should definitely either wait for Vulkan or build some tools to manage atlases and put them in batches. Or what one guy said on Discord, lol, just get a better GPU. This was really helpful. Is this guy here actually? No. And that's it. All right. So the point of this talk was to be less of a fanboy and more of a realistic person who's actually wants to migrate to this new software but these are some things that like worry me. So I'm hoping that people will have some information and like questions and maybe like rebuttals to certain things that we said. We have all these tests in all the different engines, so we can like share them and people can run them on their own builds to check them out, that we didn't like do some errors and something. So thank you very much. Yeah, sure. Yeah.
When you prepare tests for bullet hell, how did you use Godot script? Did it base it on actually code or more about GPU?
Yeah, it was code based.
Can you repeat the question for the last?
Okay, so the guy asked if it was more based on again on code or GPU. You asked. The bullet hell example, the first performance test. I'm guessing Pete. It's more like based on GDScript. It's just GDScript. Yeah. Of course, that's why it would be much faster if we do it in native, but we didn't. All right. But that's something we should also try and see how much of a difference it makes. You know.
Yeah, because if you test Unity with .NET and it's faster and maybe Godot, we may apply some different techniques.
Yeah.
Not to process each frame, for example.
So he says that we could use techniques not to process each frame and so on,
Yes.
which is all true. But the point of the performance test is to literally do something without any optimization and see if the engine is capable of doing this. Yeah. So it was just without thought, just build it with 5 lines of code, just a for loop that makes instances, and let's see if the engine can do it. You know. If there's, yeah, sure.
Yeah, I'm kind of missing the point here. According to your performance results, Unity was performing not that bad compared to Godot. So what drove your choice using Godot instead?
All right. That's actually the most important part, and it might be that I just missed it. Sorry. Yeah. So what made us actually go to Godot in the first place was that we were already working on a proprietary software, and we got what's the nice word for it? All right, so we had a bad experience, you know, because they were bought over by a gambling company or whatever, and they said, okay, let's make more money, let's make a new one, and we like made a list of stuff that we don't want our company to experience ever again. You know, we don't want to not know what the roadmap is. We don't want to like not know when something is going to be implemented or dropped and stuff like that. You know, in the far future, we don't want things to be ever dropped. You know, so if we have some legacy code, we don't want a new coder to not be able to like maintain it 5 years from now when some new console comes out. We want our old games to be on that console. Why not? You know. And this is why we wanted to choose an open source project, because it's because the roadmap is transparent. It's rising really great. So I think that soon it will be on the level of Unity or GameMaker or Unreal or whatever. Not right now, but what outweighs it in this aspect is that it's open enough that if there's a problem, we could solve it ourselves, and there is no chance because of the business structure that we're going to be like left with a financial setback because we have to buy something else, or somebody's like I mean, for example, any company, even Unity, could go bankrupt theoretically. Not now, but in like 4 or 5 years maybe, you know. And it's a big risk, you know, and it's not like it's a theoretical risk because we're at this situation now in the company just because we had this exact same situation with an engine that I've been using since 2004. So it's something that I thought was never going to happen, and then now it's like you have to transition to something that's not good. So so we decided we want to go to something that's open source, that's never going to have this transition problems, you know. Even if the community decides to go in a different direction, it's all still here. We can still use, I don't know, GDScript if they decide to go to, I don't know, Java or something. It's a stupid example, but And if that's it, all right. Thanks you. Thank you a lot.
Next up, yeah. And just I just announced that there is some more room or can bring more chairs. Some people in the room, there are still some chairs, so don't send away.
So, I have fire ongoing. Okay, welcome people. I'm from Rocknight Studios, one of the guys. We are streaming a lot actually of developing games in Godot and trying to promote Godot a lot because we believe in this engine. And if you would come to our streams, you would type !Godot and you would be surprised. And a lot of people, as I have seen here already, have been really excited to see me here, new Godot users. So we actually come from building a game in Unity, and as today's first speaker told that he could not build a game in Unity on Linux. You can actually do it, it just requires quite a lot of hard work. And we've been working on our big game already for around 5 years. And really nasty thing that we did not like is that they removed the support for JavaScript. And we use that code, and now rewriting and fighting with Unity generics with tens of thousands of lines of code would be quite a hassle. So actually we discovered Godot because it became quite popular at the end of the last year, well, the year before the last year, and we tried it out, got really excited, and we decided to check it out. What can we do with it? Start learning it. So we got through documentation and decided to participate in a game jam and make a game, which was actually in a length of month. While doing the game, we really understood that Godot is something that we dig because we are huge open source software supporters, all on Linux systems and using open source tools, and not only open source but really free software movement. And we decided that we really want to promote Godot and not only us make some game that people would be, wow, it's made in Godot, but also through that support others who would make it. And so I came up initially with a very fundamental idea to build a tool that I felt really was necessary after using Unity. Like in Unity, you could use scene view to edit your game while it's running. And basically, yeah, the idea was to build a similar tool in Godot, but with the features that I've been missing. And through that, promote people making larger games in Godot, because this tool really has a purpose, and that purpose is to cover the areas that took the most time and the hardest work in debugging the game that we are working on. And you can check it out later, ask me about that game. So I'm going to show off this tool that I've been working, and I'm going to show it in 2 games. The game that we started working on that last spring, actually on the game I haven't worked on in this screen resolution, it may behave a little bit weird. Also, the screen is recorded, so performance I hope is going to be okay. And the other one is I'm going to show you that you already can use that tool in any of your 2D games. You could also actually use it in 3D games, but it's intended for 2D games right now, so it would be not really convenient to use it in 3D games. At first I'm going to start with a very basic overview of going through this game that we've been working on and showing just the features of the tool that I've called Visual Debugger. And the tool is made so that you can easily install it in any game, basically. I'm going to show it to you in a moment. I hope that it's going to load the level in, because this game is actually pretty huge. People were surprised that on GitHub you have to download a gigabyte of data. But it's more of an art asset just put in the game, so hopefully it loads in. And then I'm going to show after this game another game which is made by really talented guy that we discovered, Securas, and his Twitter handle is Securas2010. And yeah, you can see here the Freya. And yeah, and I'm going to show off that you can implement it in other games too. So if I would start the game right now, we would get menu screen. I could start here right now by pressing F12, Visual Debugger, which would slide out here pane on the side. And you can start to do already various things, but most likely I'm going to just start right now, run the game, continue running it, and just start the level to show you. It turned red. What it did, it detected that the game camera is not the same game camera that Godot can use, and and what you should do at this moment, you should probably refresh the or open and close the debugger, which automatically refreshes scene 3, or just press on refresh, which I'm going to show you in a moment. But already here in camera tab, you can do various things. You can zoom out the level and move it around whatever way you want while it's running. And you can zoom in, of course, to the mouse cursor position wherever you want. Also, you can do crazy stuff like, for example, you can zoom to and scale the level the way you want. For example, we could do crazy stuff like this, for example, and the level gets distorted completely insanely, right? That's probably not very useful, but you can do things like that and go anywhere in the scene. Well, of course, you can also here see the total zoom, which is the gray color, and the yellow bars are displaying the stretch over value 1. And if we are going to stretch under 1, we can get the zoom, what is the shrink value. And you can see that actually it's really helpful if, for example, I would set zoom value to 0.5 here, and 0.5, you could see that you would zoom to 0.5 here, 50% and 50% here. I hope it is being displayed normally and the text is readable, because the screen is not really attuned to this. So also, thing that you can see right away here, many games can use different camera anchor modes, and Visual Debugger tries to detect the same, for the Visual Debugger camera, the same anchor mode that you would use in a game, but you can always have an option to switch it. For example, that would make it a little bit weird, but yeah, anchor mode here is fixed top left. Then this probably is going to be removed. Also, I want to remind that this tool is probably alpha or pre-alpha, so any suggestions are very welcome, and our community has actually provided loads of tips, and I have a huge list of wonderful features to implement in the future. Also, you can use cursor keys to move around the level, or you can just press middle mouse key and drag the level around. And of course, dragging around is relative to the zoom level. There are a lot of like that, which are to make it intuitive. Also, at the bottom here you can see the world position of the mouse and viewport position of the mouse cursor. And as I wanted to mention, that this GUI you can see right now, it's basically just a scaffolding for the Visual Debugger. I have actually planned to make it more intuitive. So right now, but still, anyways. Now we can do a very cool thing. We can step through the game without any struggles as you would experience perhaps in the stepping in the Godot. Though there of course are some limitations too. Also, right now I'm going to go to the next tab, and I have a question to you guys. How many of you are using remote while running game and trying to debug it or change values and try what's happening? The remote in the Godot. Awesome. How many of you guys are really excited how stable, quick, intuitive, and good it is? Yeah, and that's also one of the big reasons to build this tool, because tests show that sometimes you have to wait for 30 seconds or more to click and get the updates from the remote, or remote crashes your game so badly that you have to restart Godot to just get back to the game and start running again. So let's go to Visual Select, and here we can see something cool. We can have a selection circle here in the world, and we can actually select all the nodes that are under this selection circle with both the node name and its type. And why here is a list? Because I found it really annoying in Unity to select something and then click while finally you find a real selection. Here you can choose the exact node that you would like to inspect. For example, in this case, you would go and find, for example, let's go to the, well, there's probably a little bit too much information here, so let's make it smaller. And for example, I would love to get information about player node. And right away you can see here, also here for the, I have not really noticed in these two games problems with having a selection enabled while the game is running, but I have left this switch where you can switch on and off detection of nodes under. So for example, if you have a huge scene 3, it shouldn't take too much time to go through it and find all the necessary information. Here, now you can start to visually change properties of items. For example, I can move around this node, or I can perform other transformations. For example, I can rotate it in any direction I want. I can scale it. I can do negative scaling, for example, which is indicated here by negative, by minus, and of course the rotations aren't broken there too. Problems which you may see here is due to the resolution of the screen for this game, because it was intended to run in 1920 by 1080, and I have not tuned it for this game. I actually finished the latest version of debugger at 3 o'clock last night. So, now the next thing I would love to probably show is that you can not only do things like that, at any moment you can return to the game and continue playing it. If there are some performance issues, that is most likely because this laptop is not tested and is being recording screen. So what I wanted to say is that now you can do various things, like for example, you would love to follow the node. Now the screen is going to follow. You can zoom out, you can observe the level. For example, there is shader working in an action, and you can move the level around and it's going to follow, or it's going to follow from somewhere to indicate where you are moving from, or it's going to follow exactly right away to the position where you are moving. Now, of course, you can always stop and step through and zoom in wherever you want to do it. Now, what should we look? Here is a path to the node. That's probably going to change in the future too. And of course, you can also not only follow the node, that may be changed, but you can always select jump to node, and you're going to move to that node in the world. You can improve the movement speed with the cursors too, which I forgot to mention. Anyways, next and probably really useful feature that many of you would enjoy using would be watches. So you actually get the full scene 3 loaded in, and not only the level, which is observable here, and we can get to the player or any depth here, and you can do both vertical scrolling. You get the horizontal and vertical. You can get the node type here, and also it's indicated by icons, of course. And now, for example, if we would love to explore what's happening with the player node, we could actually add a watch to it. And for example, we would love to know position of this node. We could add watch, and now we can see we have an watch, which is here indicated in the node type by the icon, and we can also horizontally scroll through and look that it's a player nodes watch with the name position value, this position value, and type vector2. Not only that, we could, for example, also add other nodes like modulate, for example, and we could see that it's a type color value 1111 and modulate watch of the player node. Not only that, we can do deeper drills. For example, we would love to see what's happening with the camera's position, and so we could enter the, for example, position of the camera, or we could enter also, I don't know, transform. We can return the transform of it, so it's going to be actually a longer line than rest of the lines, but you can still see and observe what's happening there. Now, not only that, you can filter data. You can filter what you want to see here in the list. For example, you would love to see only raw data. It should be unique, and you would only want to see values, which you could then take and, for example, for later on analysis. That's cool. And then if we would run the game here, I should not done that. I should run it here. You can see that actually the values are being updated, and now we can actually follow the node and we can see the values being updated for both camera and node, and you can inspect step by step what is happening with the world, and you can see the potential of it. In the future, we could reset your game in the past and try again. Or you can see the wonderful coolness that is here, loading instantaneously the tree and having the visual debugger here in the tree itself. So you could actually create automated tests. You could write a test that would make the debugger perform certain actions, and which you could repeat and actually do sort of a unit testing while your game is running, while changing initial conditions, for example. Probably that would be initially what I would love to say about it. Let me see if I haven't missed anything. I think that for this game that would be enough, and now I'm going to show to you guys, when you get the overview of the tool itself, that you can use it in other games too. For example, Sakura's game. So shout out Sakura 2010 on Twitter, his Twitter handle, and we can open. He actually participated in last Godot Wall Jam, and he got to sleep before the submissions ended, and his game is actually amazing. We streamed the Godot games from the Wall Jam, and people thought that this game should have won actually the competition, the 3D game. So his game, this is different game, but this game is called Crackshot, and most likely it is going to produce some sound, which is actually a pretty cool sound there in the game. And yeah, the computer doesn't want to behave very nicely when it's being recorded through Chromium. I hope it's going to load the level soon enough. Come on, Godot. Okay, cool. So now, if I would run the game here, then let's try to use it in a different game while it's actually fully running, fully working game. Plus, huge difference is that that screen size was 1920 by 1080. This screen size is actually, let me see quickly to not lie to you, window, and the window is going to be 400 by 225. So it means you can actually scale the visual debugger size. We probably would have to set 2D mode to have text readable, but you could actually implement it basically in any game, which is 2D most likely at the beginning. So if we would run the game and make it larger, we could start the game. There's a nice little character. We can run around. And we could, almost died. And we can do a lot of cool stuff like that, but at any moment we can drop into Visual Debugger. Here you could observe that something changed, right? The problem is that anchor mode for the camera was differently set. Also, I forgot to say that there is shortcuts already inbuilt. What you can do, you can actually press F9 to step through. So for example, this game shoots when you press left mouse click, so you would not really want for the game to start shooting. Also, you can just press Ctrl F9 for the game to continue running. You can press F11 to do center around mouse cursor. So for example, you can press here to this coin and the screen is going to center around the mouse cursor, and you can quickly move around the level to any place where you want to observe any enemies without, for example, zooming out. Of course, you can still use dragging, but it's a little bit more efficient way to do it. And of course, you can zoom out the level, look its layout, change any parameters you would like. For example, let's get to this little guy here. Let's, for example, stop the game a little bit. Let's go to Visual Select. Let's select this guy, which is going to be probably this one. And let's just make, for example, it to be monster enemy. Let's make it to be really big one. So for example, you can quickly check various ideas how they would work in your game. This tool is intended to be more of a debugger, but I actually plan in the future that we could add features like visual design, where you could actually more of a design your game. And there have been a lot of suggestions from community what people would want, and actually there are a lot of features like filtering by type, by name, etc., etc. For example, one feature you don't have in the remote, you cannot filter nodes by name. That's going to be available here too. For example, now if I would run the game, the monster would walk around there, we can return actually to game like this, and you can see that monster is there, and it actually collision is also at large, so you can shoot him. So now we can, for example, jump past, and let's not go in there. Let's go here, and for example, we have to reach this altar. We could try to do various things, like for example, what would happen if we would go and change the altar's position? For example, will the player is going to be able to, and we can also do that here from, we can select all the nodes that you do in visual select. You can select them here also in the scene selection, right? But you can see why sometimes it can be very useful, while in this case it may be a little bit slow. Find where it is in the scene structure. But here we can really quickly find the node, and then we could, for example, try to put it here. Can we reach it with the player? We could actually run it while the game is, we can run the debugger while the game is running, and we can see that it's working. We can follow the altar, or we can follow the player. So for example here. Yeah. And yeah, and you can do crazy stuff like, for example, reposition player at any moment. Here we can see it's red. We can refresh the tree. We jump here, but it's not a real problem because we can quickly get back to the player's position by centering or zooming out, zooming in to where it's in the world. And you can play the game while it's being debugged. And for example, let me quickly get to this guy, to little girl, and for example. Let's set her, and we can now play the game while it's being debugged, and we can do for example, oops, well, I died. And I can refresh the tree and select the camera mode. So, and that's also one of the things I would love to, for this tool to be evolving with every game. You can implement it in your game, add any features you would like to, and it would spark good implementations for all the other users of the tool too. So I think it could be really exciting that it's independent of any Godot version, and you can just update it with your game's needs. And for example, yeah, we could also use it with camera here, and we can use the player and, for example, let her fall down to her death. And so yeah, I think that this would complete the short demo of the tool. I would be really, really excited to have any of you to ask any questions. If you have any of your games, that would be, I'm sorry, the mic fell down because the wheel of the chair is over the mic. I am sorry, that's terrible. Hopefully it didn't ruin the whole live stream. And so if you have any of your games, I would be really excited to check it out. Can we get this running in your game? I think it should be very simple. I made a simple GitHub repo with the debugger. You can just copy the folder in your game, add VD Global to your autoload, which is actually amazing in actually implementation of singletons in Godot. You can add such features inside of Godot really, really easy without making custom implementations of singletons. And yeah, guys, you can actually also, we are streaming every weekday at Rock Knight Studios at twitch.tv. And if you have any questions, do come by, ask them, and I'm going to answer you live. Any of your questions. So that's it from me for now. Thank you so much. And do you have any questions? I would be glad to answer.
Yes?
Yeah.
Are there any fail-safe in the case you screw something really up in the debugger and...
The changes are being reset as soon as you stop game. It's being reset. Actually, I have not implemented saving and exporting game state, but I intend to do it for, as I said previously, visual design tool, something like that. I don't want to do everything right away, but that would be an awesome feature that you could actually save and do online editing of your levels, really. Yeah.
To get the speed value of the player,
Yeah.
do you have to give a specific name to the variable to get it back in your debugger?
Well, you don't have to. What you are looking at watches, that's basically getting the actual property of the node, right? It's looking, does the node has this property, and if it does, it's going to return all the data for you: node, watch type, watch value, which node it belongs, and yeah. And you can. That's the amazing thing, guys. I want to repeat. I've been working on the big game that we've been working, and it has been swallowing so much time, where you have to make very intricate tests for specific characters in a huge world where it moves around, and you have to detect very, very particular problem, and you have to repeat it. And it's amazing time saver when you can set it up the way you want and do drill of many nodes and how they behave and interact between each other. It's really huge time saver. Yep.
Yeah, I'm wondering, did you try how does it play with viewports? Like if you have like multiple viewports.
Yeah, actually, I have written for myself. We could actually quickly try to make a little demo of 2 cameras simultaneously working, but I don't think that's probably. I could show it later to you, especially. Yeah. So I can try it, and it does work. Sort of. It does work, but you have to make it specific for your game. For example, there are issues like if you are creating a viewport that is a child of a scene that's under a viewport, then there may be a problem, which is likely a problem in Godot. At least I read in the GitHub that there have been discussions on that topic. That, for example, viewport, if you would run the game, then if you would run the debugger, then run the game, you seemingly won't be able to click anymore on debugger. You have to close it, open it, or you could go to that viewport that is a game viewport and set its GUI to off, for example, in remote or in the visual debugger itself. What's more convenient for you? But yeah, you can do it. It works. It's basically in a game you can do whatever you want in a Godot game. You can do it. And wonderful thing is about, again, huge benefit. Think of it. You can run it on any device. You can actually do debugging on any device.
Nice.
Yeah. Could you please speak up a little bit?
Could you just give us the URL?
Yeah, of course. I'm sorry if I have not done. You can do 2 downloads. I have not put Crackshot download, but you can download both. Freya, the Wildcats, and I prepared yesterday with tips the GitHub repo for. Should probably have I copied it here. Hopefully, yes. Here it's going to be. I marked some notes here. So, guys, you can see, and actually come to me. I'm going to share again a card, and you can check us out on Twitch. And going to answer any of your questions. And going to dance for you. If you're going to type !Disco. So this is first one is Godot Visual Debugger with instructions. Pretty cool. I hope it's going to open if I'm going to click on it. Will it open? Please do open. Maybe it's going to try to open Firefox. So it may, yeah, it's going to do in Firefox. Yeah. I do not use this computer. I gave this computer to our artist, and he's struggling with it. So, and yeah, and here you have, I prepared this last night. So, I have not tried it 3.1 because on my big computer, actually, 3.1 doesn't work. I have driver problems. But on this computer, it does work. So, yeah, I decided you could do installation even easier, and Benny is in the house. Benny is actually suggesting that he may help me to make it in Asset Store, so you will be able to install the debugger from Asset Store as well. But right now, basically, installation is really simple. You could avoid even this one, but I decided that you could set custom button to call, open and close the visual debugger. Then there's how to use, a little FAQ of the most common questions that I thought that will be. Actually, here I mentioned that about viewport, and yeah, and you can check us out at twitch.tv Rocknight Studios. Yeah, and so again, I'm going to leave that those links here so you can. I am terrible with this microphone. It's and I think I broke it. Cool. Any more questions? 3D. It does work, but the visual selection part is intended for 2D. I do not guarantee that it's going to work, but you can start it, get whole scene 3, and do whatever you want with the scene 3. So I have not really tried it out, and that's one of the things also. We really wanted to wait for Godot 3D to become a bit more mature because we dive into it. We wanted to become, this actually started as a learning project in Godot, and we wanted to get really good at 2D, understand the Godot's API, what it does good, what it does bad, and so to really know what should we implement in that game. And we actually have it in pre-production. We just have to now push that Unity project and finish it, so that we can go fully for Godot. So, any other questions? Yeah.
So you talked about the watch window. Is it also possible to have a kind of immediate window, like the same thing, but for to actually not just evaluate these questions, but apply action?
That's planned. That's planned. Not yet implemented, but I have it in my to-do list. And if you're going to come by and if you're going to give suggestions, I'm going to be more than happy to speak with you. And yeah.
Maybe repeat the question for the stream.
Oh, I'm sorry. Yeah. So the question was, right now you can look at watches, the values, the properties, members of the nodes, right? And the question was, could you apply functions and like basically method calls on those nodes? So for example, change behavior, and that's planned. Yeah, and actually those node inputs actually, you guys, I forgot to show it. You can in real time change the values. You just have to right now know the form, and you could change the color, position, whatever you want just there. It's not just displaying, you can change them too. Yeah.
The first thing, Godot Visual Debugger, is it working for everyone?
Yeah, you just, well,
I opened and I don't know if I do something wrong, but it seems it's not easy to open.
it's not a Godot project. It's you have to follow the instructions. You have to have a running game. Copy.
I only want to open the first link,
Yeah.
Godot Visual Debugger, and I don't see it. I don't see it on your Vito page.
Ah. Really? I just opened it.
Okay.
Might be a typo. The first link works.
Yeah, it worked. I just checked it out. So.
Maybe only for me if it works for everyone.
Well, we can discuss it after that. I'm going to be more than happy. So guys.
It's not,
Yeah, we can check it out. We have time. So, do you guys have any other questions? Yeah.
One aspect about the build platform, basically, I wonder if you are using editor 2 API, for example, Joe, the node hierarchy, which would make possible only to have this debugger and some build configuration.
I get.
Are you rebuilding from scratch all the transform tool, node hierarchy, printing, watch?
Yeah, basically they are built from those tools you've seen. They are all built from scratch. So.
I just see the table of the node hierarchy here, so it's not at all the same as the node hierarchy.
Oh, the scene 3?
Yeah.
It's exactly the same.
Okay.
So it's basically the same thing that you would see in the remote.
Okay. Because,
But you can access it quickly. You can set values quickly. You can debug it in various drills.
they were expecting, those kinds of things to be stripped from the build, a bit like a Unity editor in space.
Yeah.
When you build a game.
Implement the scene tree yourself.
I got it. You mean you want to, when you build a game, to remove the visual debugger from your game, right?
No, actually, I'm just asking how it's possible to access these functions from the editor, because I would expect them to be stripped from the normal build. It seems like you're able to.
No, because Godot, because visual debugger is a part of the game itself. it's not in the. That's the difference between, for example, Unity and Godot. For example, in Unity, if you would run the game and the game would crash, there is a likeliness that the whole Unity would crash together with the game. In Godot, you have this wonderful thing that editor and the game, they're in different contexts. So if the game crashes, editor is going to still be running. And so the cool thing about this tool is that, yeah, it can crash your game, but it's going to crash only your game, and it's going to work with your game no matter what. You can build, like, the controls won't work right now if you are going to put it on, for example, Android or iPhone, right? But if you are going to do a little changes for the controls, for example, to have a GUI buttons to tap on them, right? You're going to be able to have your Android and debug your game while it's running on Android. It's just part of the game. It's loaded in the auto load as a singleton in the game. Yeah. Wow, wonderful questions. I'm glad answering. Yeah. So that's it. Yeah, of course.
You mentioned maybe being able in the future to record the actions to perform automated tests.
Yeah.
Maybe like give an estimate when there are
well, okay. One thing that I'm going to tell you now is that this month is going to be I won't be able to work much on Visual Debugger at all, because it's going to be crunch time for the first beta version of the big game that we are working on. So it was actually quite a lot of work for Visual Debugger until this presentation, and then I'm going to work on that. But if it's priority, then I can set it up as soon as possible to start working on that, right? And there are a lot of things. For example, I have not looked into if it's possible in Godot to save the whole game state, right, and move back in the past and forward. Right now, you could do that. You would set specific watch values, and it would be pretty easy to save older version and go back in the past and forward. So do crazy things like that in your game. But it would be limited to those nodes that you selected, right? It would be cool if you would reset everything back and forward. When we can see, I have not just investigated it as of yet. Yeah. So yeah, I'm glad that the potential is great. Yeah, man, cool.
Yeah, simple question. I guess in the future you intend to try to have it integrated directly in the Godot project.
Actually, not really. Well, it's going to be sort of, as we spoke with Benny here, he would really love to help me out to make a very easy installation from Asset Store, right? You would just one-click installation, though it's again right now it's pretty easy to install. But really, I would love for it to evolve for any game's needs. It's under MIT. You can do whatever you want with it. It's just the same license as Godot, right? And I think that it would be more freedom. I would love for it to evolve in different versions and people would be able to communicate. But I do not know what's going to happen in the future. I hope it becomes popular, and I hope that I provided enough evidence for you guys that you could see that the immense potential of it, right? But you could do with it and how it could evolve in the future.
Why I'm asking is because I'm lazy, so if it's directly in the editor, I don't have to install some third-party tool to improve my editor. But I know it's still alpha, so it's early. But I don't know if it's in the plans to maybe have one.
It has not been. It has not been yet in plans, but we could put in the plans because community rules them all, man.
Discuss with the most.
Yeah.
I'm not actively contributing, so this will have to be.
Yeah, but.
With those who know better than me.
Yeah, I actually have not contributed to Godot C++ code anything as of yet, also because of the busy schedule that we have. But I would love to.
Well, I don't want to sound like I want to force a relationship, but one is a free open source engine, the other is a very cool debugger library.
Yeah.
Let's get this.
But it's basically, it's already there, and why not? Yeah, of course. It's just it's in working in different contexts, right? That's why I'm don't see right now that connection that well. But why not? We could invent, like, Godot is developing so quickly. Like, guys, it's amazing. I converted one person. He knows who his name is. He used default. Now he uses Godot. And he got working in Godot in a few weeks and is already making games in 3 hours. We are making Game Jam every Saturday. If you want to participate, it's just 3 hours of your evening time. You can participate. Actually, this evening, guys will play games from the last one. And he actually, you will be looking at his game that he made. It's amazing. And my point was that when we tried compared his version 305, he had the 306 and I had the 305. There was actually essential changes already in the engine, which I just updated and got already for free many upgrades. So Godot is evolving so fast, so that yeah, anything is possible. You can see that people are showing, yeah, we have some performance problems, but man, come on, few years in the future and we are going to fight with the big guys. Yeah, so, yeah?
Not really awesome stuff, really. Not really question, but like a use I see is that you can also use this as a setting breakpoints, right? You could, in your code, for example, do a visual debugger, but not open. So the debugger would open at that point in your code.
Ah, that's a really good idea.
Would that work with the flow? Like, would it stop at that point or wait for another thing to finish?
We can discuss it after probably, because now the discussion would be probably too long about that, and we could look what's the best option. But yeah, man, do come by. Suggest if I forget, remind me. I have to note this down, man. Very cool feature, and it should not be that difficult to implement too. Yeah. Yep. Duplicate what, excuse me? That's actually one thing that I'm really trying to do with this tool. I do not want to overlap with the features that are already in Godot. Or do I make something new, or I improve something that is not satisfactory for me. You can still use profiling to profile the visual debugger to debug it, and editor to edit, and etc., etc. And at the same time, you can edit the game with the visual debugger. I really don't want to make fool's work, right? To just repeat what's already there. Because Godot is amazing. Like, the scene 3 is like one of the God's gifts, I don't know. But you cannot imagine. I've like in Unity, one of my big gripes also is that you cannot set script execution order. You can set it in the script execution order manager, and you can move components around, but you cannot say which update function is going to work after which update function for various nodes. And that can introduce immensely, like on a larger projects, asynchronization becomes a nightmare. For example, you can work your game working in editor and not working in a game, working in one editor on your friend's computer, not working. It's terrible. Here, oh, I have to fix that problem that I have to spend there 3 days refactoring my code. Let's drag this node up here. Good.
Well, thank you. Thanks a lot.
Yeah, my pleasure. And I hope that I won't have to pay for this microphone. Because I don't know where this clippy thing... it's here.
saw it already. You will go a bit more into details for Godot users.
Yeah, yesterday's talk was very constrained because it was only a bit less than 40 minutes. So here the idea is to do it again, but a bit more relaxed, so I can show the processes in more detail. That should hopefully fully help you understand what the processes here are. So, well, first, welcome everyone. Thanks for being here. It's amazing to see this event has grown so much since last year. It's pretty impressive. Let's hope it keeps growing like this. So, well, the idea of these talks is is more than explaining you. Like, this sounds like a business talk, and it doesn't have anything to do with business. But if you want to ask me about business, that's okay. Run a company for many years, been consultant with business, I can answer. But it's not the idea. The idea is explaining that you can do something really nice by using only free software tools. So, what's the motivation for this talk? You know, a year ago, Godot 3 was released with a new rendering engine. It's still not completely full of all the features that we would have liked to have. Needs more performance fixes and things, but it was something completely different to what it was before, which was mostly a 2D engine or barely 3D, just for mobile. The Godot 3 engine had a lot of new features that are more common in the high-end engines, so the idea was that we needed something to showcase it. The engine was made, but how to show people that you can do something really good looking with it, so we need a demo to showcase it. Godot always had a 2D platformer demo. Is there anyone in this room who didn't check the platformer 2D demo? Oh my god, there's only one person. Okay, that's good. We also have a 3D version that looks pretty bad. If you haven't seen it, I have it here to show you how bad it looks like. Let me go full screen. This is pretty much just like the 2D one, but made in 3D. Honestly, it looks really bad. I made the art myself, and I made all this myself. The idea of it is more like, if you learn how the 2D platformer works, this is just the same code but made in 3D. It's not really meant to showcase the engine. It's more like so you learn how to make something in 3D after learning how the 2D ones. So yeah, 3D version looks pretty bad. With the new renderer, Godot is capable of much better. So here's where the journey began. Interestingly, the artist who worked for 3D for the new demo is the same guy who made the pixel art for the 2D platformer demo. The 3D one is my art. I'm really bad. But the 2D one, the pixel artist, the guy actually is a professional 3D artist. As he's one of the best ones in South America, where I live. So the idea was to hire him to do the new demo. We started with concept and prototyping. One of the ideas was like, if we want to make something that looks professional, it needs to be like trendy, like futuristic. Now futuristic games are like all trendy now. You know, medieval. How do you say that? Okay, medieval games are not trendy any longer. This is not 2008. Now games have to be futuristic, retro futuristic. Actually, I think is the trend now. We wanted to make a level that is curved, because when you make a level that is just too blocky, it looks too amateurish. So if the level is more curved and has more curves all around, it usually looks more professional. We wanted to make multiple rooms, just so you can see how the lighting conditions change. It had to be short, but it had to be pretty. The idea is that it's pretty, it looks really nice, like packs a punch and just short and nice. What you can see here is the layout we made. You would start like from, oops. I broke it actually also. It would clip in if it had still the clip, but I broke it. I probably here. Sorry guys. Here it's working again. Sorry about the technical difficulties. Okay, should be working again. Okay, now be more careful with the cable. The idea is that you start here, you walk from a deck, then you go to a lower deck. At all times you can see this abyss, this huge abyss. You fight a few enemies, then you cross a bridge and you get to the reactor room, which should have a pretty nice reactor. Like nuclear reactor, but it's not plasma reactor, whatever. So this is the level blocking. Having worked like a lot of time professionally, what I can tell you is that you start always with a level blocking, which is you can see it's all basic shapes. It looks, if you're like not very trained, this looks like an untextured level, but actually this is all very basic shapes like squares and circles, and nothing has a lot of detail in here. The idea is to just, you get an idea of how the level is going to look, but the art is not even close to final. The geometry is not textured. The geometry is too simple to be the final geometry. We did this level blocking just to make an idea of how the level was going to be. This was done like in 2 days by the artist. When you're a professional artist, you can do this kind of blockings really quickly. This helps test the game flow, the dimensions of the level. Let's see if the game looks good, and when the camera looks, what is it looking at. Also helps to test the lighting and to test ideas for lighting and everything else. The next thing that we did was character prototyping. One thing I learned when working at 3D games is that you should never use placeholder animations for your game in 3D. Because animations are just part of the gameplay and the control and the feedback. So even when prototyping, you need to do final in-org animations that they represent the final version of the game. This is done in Blender, as you can see. That model is not the final one, but the animation is done in Blender. Was prototyped in Blender. We did gameplay prototyping. Here you can see the character. This is the new robot. Also, there's some kind of problems with LibreOffice video playback, which seems to be some bug. It seems to have bugs. Well, anyway, what you can see there is the level prototyping. Well, it doesn't look too bad. So, control must feel good. Interaction must feel good. Wow, it closed. Okay, come on, you can do it. Here. Okay. We use the animation tree. The animation tree helps you communicate with the. It's a tool that helps you communicate from programmer to animator. This way, you can like set up and prototype all the animation transitions and everything related to all the possible states and blend states and filters and everything that all the animation is going to have. It's very good for just communicating with animators and to organize all the very large amount of animations that you usually have in a project. This also was done in the prototyping stage. Godot has root motion. Let me show you this actually running on the editor because this is like sucking. The video is not super good, I guess.
If you want an interesting fact, the glitches are only on the screen. Screen sharing is not seeing glitches.
Wow. That's quite a mystery. Here you can see the robot scene. This is the more final version, of course. You can see the guy did a pretty nice job. If you have been using some Godot, you can see that this here is the scene that has been exported from Blender. Here scene root, it says like bat.robot.large.day, which is the Godot file. We just instantiated here, and we said editable children, so we can have access to some of the things like animation tree was created here. You can see like all the animation state for this character. Has a few one-shots and different things, but it's just in there, I guess. Has different like blend animations and everything. Well, that's pretty much, and it also has like root motion. So when it went away, okay. Yeah, it's kind of weird. Sorry, no, and not used to LibreOffice. Had to use LibreOffice because Google Docs wouldn't stream things. Well, Root motion means that when you animate a character, the character animation is built into the animation. Let me see if I can show you this in Blender actually. So now that we have a bit more time, I will close the engine. Wait, I might hate this in Blender. So this is the Blender scene. I can show you the animations for the character, which are here. If you can see, when the character rotates, it actually rotates. It's not done in place. You know, in games like more than 10 years ago, when characters were animated by animators, they have to be animated in place, because when you run, like, you stay in place and you actually animate the physics. Nowadays, especially since Assassin's Creed, what is very common is to do this root motion thing. There is a bone, which is a root bone, which is actually animated. The turn animation is animated with a bone. So what is done with the engine later is to just nullify this animation from the bone, so the thing remains like completely in place. Like, for example, where is the walk animation? One of these is for walking. This one. If you see, the guy actually is moving forwards. This allows, using root motion allows you, as you can see, that the foot or whatever is touching the floor remains aligned, because the animator animates just the actual motion, and you can see that the foot are really nicely aligned when the guy moves. Root motion will just cancel this motion and will leave the guy in place. So what we will do later, I will show you in code. If I can show you what this is done in code, is pretty interesting. Oh, I'm in the wrong. Here. Where is the script? You probably have used the move and slide function in 2D, right? Like, I'm pretty sure most of you made 2D games and use the new move and slide function. So this is the code for the robot. Okay. As you can see, this is pretty interesting. Here, in this line here, I will try to make it bigger because it's probably very small in the screen. Can you see it better now? Here, the animation tree node, which is the one with the animation tree, you can get the root motion transform. This means this transform that is happening in the root node, which is what the animator did to move the guy so the foot aligned to the floor. This is nullified in the animation tree, so this isn't applied when you move the guy. And then instead you can retrieve this transform. So what is done here, as you can probably see, we just get the velocity from the root motion, like get the transform divided by the delta, which is the time happening in the iteration, and then it's fed to move and slide. So it's pretty cool because it has collision and everything, but it moves according to animation. Like you can do this combination of things. So you can have something like in games like in Assassin's Creed, when you have the guy moving and it's super realistic because the foot keep attached to the floor. And if the guy moves to the side or does anything cool, the root motion will ensure that the guy will always move according to the artist's animation. But we need to move and slide in Godot, and then that means the guy will collide if it has to collide, or will just keep walking over a surface or up and down. So this combination of things is very useful for 3D games. Okay, let's continue. So VFX is something you probably should try to make final in your game. The VFX are part of the feedback of your game. So if you prototype, you should probably try the VFX to be as close as possible. This is done with Godot. I will show you in the engine now we have a bit more time how this is done. This is actually pretty cool. Again, the same scene. You can see here, this is the actual scene that was imported from Blender. This is a bone. You remember, this is a bone attachment. This tracks the motion of a bone. It's tracking the motion of the cannon, you know. has this cannon over here. The bone attachment is attached to the bone of the cannon. It has a mesh which is a ray, which probably you're not seeing it now, but this is actually the ray that it's shooting. So it has a material and it has a shader, and this shader has a clip distance, which is is it visible right now? It may not be visible. Let me check. No, the ray is visible. So transparency is this. I can put it to 1. Here you can see the smoke. But actually, this shader, what it does is, let me show you. Can go from 0 to 1. Well, I will show it animated. It will make more sense. I have shoot animation. This animation changes parameters. Here you can see it animates the ray. I will just shoot so you can see it. Can you see here? This is when the guy shoots. It just draws energy from the air, and then you can see from the animation player it's animating many shader parameters, like the smoke and everything is part of the parameters. It turns on a light when it shoots, then turns it off. Then it puts particles to emit and then stops emitting the particles. The explosion also emits particles. It even like disables the animation tree, so when you're moving it doesn't annoy you. It's like calling functions. Like check, this is should check. Here it's checking. It calls this function, and the function checks if the guy is hitting something, and then just resume moving, because the guy will stop, then shoot, and then stop moving. This is all new Godot 3.1. You have audio clips, so you see when the guy shoots. You may be able to. I will raise the volume here. So this is all done with the animation system in Godot, which is pretty amazing. It's that this is something like pretty unique to how you do things in Godot. You just can look at all the things that you can like change to just do this shoot animation, check if it's hitting something, resume walking. Well, all the VFX are done with this, and you can see that it's affecting so much like shader parameters, lighting conditions, particles. It calls functions. It plays audio. You can do all this very nicely with how Godot does animation. So let's go back to the presentation. This is how it looks when you're working. This is all in the prototyping. Maybe you should actually play it from here. I don't know how to make it work. Okay. At some point it was working, then it just stopped working. Hey, it's working. No. Yeah. Not any longer. Well, anyway, you can see how it is. So texturing. This is something very interesting. If you're working on 3D, it's interesting that you know how to actually do textures yourself, because you may actually need textures, and you will not always find them on like royalty-free sites. There are a few royalty-free sites, but you can't always find what you want. So this is a short tutorial on creating a texture. I will show you how this works in GIMP 2.10, which is really amazing. As I said, you can find royalty-free textures around, or you can create it from photos. And if you're using a realistic style, you can use Krita and paint them. But I'm not good at that, so I can't teach you much how to do it. This tutorial I will do in Live. I have this photo, which is from Roman ruins. I took it myself. This is the photo you can see. This is in GIMP. This is a photo. I just went with the camera, like check, and took a picture of the floor. So how would I make this tile? I need to make a tiling texture. So imagine I will just make a Godot project, so you see what happens. This is how you create a Godot project from the command line. Done. Oh, yes, here, that's true. So, well, anyway, that's it. This is the empty project, so I go back to GIMP. I will save this. floor.png. So back here, you can see the texture is here. We'll just make a 3D scene, mesh instance, qual mesh, new material. I will put texture in albedo, and it's quite big, but it's done. We'll make it unshaded. So I will scale this like 3D, and let's make it tile. Here, just so it's clear, I will remove the origin and the grid. Here you can see how this texture that I took, this is what happens when you take a picture and then try to use it as a texture, especially a tiling texture. You can see it sucks, doesn't really tile. So how do you make this thing that you see here an actual texture that is tiling beautifully, and you can just repeat it and use for whatever you want? I will go back to him here. The first thing you have to do is just find a region that may somehow be tiling. So here, then you crop it, like for example, like could be something like this, I guess. Yeah, this region may actually be. Something like this could work for tiling. So let's do it, then save it, then back. Well, it's more like better, but it still doesn't look very good. So the first problem we're going to solve is this problem that there is like a gradient. You see that it's in one side is bright, the other side is dark. With the new game, there is a really nice tool which is called high pass filter. It's here. It's filters, enhance, high pass. This is literally a high pass filter. Just removes low frequencies. So just check this until it looks somehow okay, like this is totally gray, and then gives it some contrast. If you go too much, the gradient will remain there. So this is kind of okay. Then you can check the contrast, so it doesn't look too horrible. Let's say it's okay like this. Let's save it. Then we go back. Oh, you see, there's no longer a gradient, but the texture still remains there. This is the first thing one needs to learn when doing tiling textures. Just high pass filter is very useful for making tiling textures. It gets rid of the gradients on the pictures you take. It makes them very flat, so it gets kind of rid of a lot of lighting. So as you can see, I will get close, and there are still discontinuities. Like this texture actually is more difficult to see them, but if you look for them, eventually they should appear. Like here, is it? We have discontinuities here. You can see it's not like totally. It doesn't really repeat perfectly. It's like close, but it's not quite there. So there are two techniques to do this. One, which works for more of the general case. You can do layer effect here. You can do transform, offset. You say half width and half height. So you can see that the discontinuities become quite visible here. This is just the same texture, offsetted and wrapped. So the cross that you see in the center is actually the previous borders of the texture. So easiest way and more generic is you have something called clone stamp. I think it's one of these. You just select a region and then paint like with this. You can just fix it with the clone stamp. Like it's kind of like okay. I rotated by mistake. You can use the clone stamp here, and it will more or less fix the discontinuities. It works more or less. Just probably you need to do it a bit better than what I'm doing. So this will you will save it, and it will just you don't see them much more anyway, and you have a very nice floor texture for your new temple. There's another technique I really like. Let me undo this. It's more like an automatic way of doing it. This is the previous one that wasn't looping. Is it? Or is it not? Yes, it is. I really like this one. It's very easy to make something tile. I will first duplicate it, duplicate the layer. No, not this one, this one. You see I have a layer above, a layer below. I will hide the layer below so it's clearer. I'm working on the layer above. GIMP already has something to make texture tiles, which is called make seamless. You just make filters, map, tile seamless. But it kind of sucks, you know, this is destroyed, this is destroyed. It doesn't really look very good because all it does is just make a crossfade of the texture, just make like a crossfade. So the texture crossfades itself, and this just layering above itself looks really bad. So since all we care is that the borders will wrap by itself, I mean by themselves, all you have to do is do the tile seamless, but then just grab the eraser, which is probably here. Let's make it a bit bigger, and just like erase everything. Oh, sorry, this is not the eraser. It is not the eraser. Oh, I thought you had an alpha channel. Oh yes, you didn't have. Okay, now thank you. Now you do the eraser. Just leave the border. Just make sure nothing of interest gets like crossfaded, so you just leave the border of the image like this. I don't want it to crossfade. This I don't want it. So this is only the part. And once you have this, like this was, remember you need to use the tile seamless effect, and then you draw everything but the border. Then you just have a magically tiling texture with this. You don't have to do like anything else. It's just magical and it just loops. Because all you care is just keeping the part in the border, which is one that will blend into itself. And then I go back to the editor, and you can see that you won't find anymore any kind of discontinuity. It will look fantastic. I really love this technique because it's like tiling textures with no effort, and they always look great. So then there you have it. Remember the way it was before, like now it's looking fantastic. No gradients, no discontinuities, like it just looks great. Yay. So, yay. But it's not enough. There's more. You probably want to, this is unshaded, but you probably want to add lighting to it. So I will just remove the unshaded. I will add a light. Let's put a light in here. So you probably want this to include normal mapping. I will just give a bit more energy to the light. So this is completely flat. I just move the light and nothing happens. Normally this should have normal mapping, but you don't. So what you need is to create first a height map. Actually, do I have the normal map plugin installed? Filters, let me check. It's not installed, but it's not a problem. I will install it if my internet allows. Please internet. Oh, okay, that was fast. So let's restart GIMP. Yeah, it's a separate plugin. You have to install it separate, but it's okay. So I should have it now. Yes. So to create normal maps manually, I'm going to talk tomorrow about doing this for 2D games because Godot supports 2D normal maps. But it's kind of the same. You need to create your own height map, which means like what is black is like far away, and what is white is close to you. So you probably want like to have these things in between the tiles to be like black, and the tiles you want them to be white. You can paint this manually if you want. If the texture is not too complicated, you just could paint this, and especially if you're good at painting. But in this case, doing this would be really complicated because the texture is really complicated. So a simple way to do this is just use something called embossing. You just filter, it's one of these, like distort, emboss here. And then you can see that it kind of resembles a height map. Like what you see that the things like here, the spaces between the tiles are black. You can use embossing or any other type of edge detect to generate this. Fuck, I rotated without wanting to rotate it again. It's like Blender. I press Shift and this rotates. So yeah. So then I have this. Once you have a height map, remember, depending on the texture, you can paint it yourself. You can just figure how to get. But it's important to know that what is black is what is far away, what is white is what is close. You could just use the curves tool if you want to adjust a bit more. Like, then here you can tell more white, more black, whatever. Once you have this height map, this plugin for GIMP is great. It's called GIMP Normal Map. So you go GIMP Map Normal Map, and then, well, it's quite. You have different ways. You can check which one you like the most. Like, for example, and whatever you do, you have to invert the Y coordinate, because standard normal maps usually have inverted Y. So there you go. You have more normal map from the previous texture, and you can see it's pretty close to what you would expect it to be. So let's save it with another name. Where was I using this? Floor normal. Then we go back to Godot and edit the material of the mesh instance here, and normal map enabled, and let's just put it here. And then we have normal mapping. This one is probably too exaggerated. You can just change it, or you can change the scale if you don't want it that so whoop. Maybe a bit less is okay, whatever is okay. So if I move the light, you can see that it now applies the normal map properly. Like, whoop. So well, that's a kind of the idea. You just can create your own normal maps and your own textures this way very, very nicely. One thing that happened here is that when I created normal map, probably I lost the tiling in the normal map. So there are lines here. This happens because the normal map filter destroys the tiling pretty much. So you can see here that filter map normal sorry filter layer transform offset. I will do this, and you will probably see that the normal map plugin is breaking this. So you probably remember how to fix this now. Just duplicate the layer. Again, filters, map, tile seamless. It just does a crossfade. Then eraser. I will hide this so it's clear. We'll just use the eraser again, like just making it like tile again. Yay. There we go. Now it's probably just tiling again, so I will save it again. Oh, export normal map. Then when I get back, you know that you see that the lines that appeared because of the filter disappeared. So that's it. Well, that was creating textures. I hope it was useful to you. So let's go to the presentation. Now modeling. I will explain you a few techniques for 3D modeling. One that is very easy to use, and the one that we use for the demo. This is called atlas-based modeling. Basically, you need to be in a mindset of an artist for this a bit. Like you just you create an atlas, which is like there are like two wood planks and some kind of round wood thing. It doesn't have to mean anything in particular. Just create variety of shapes in a texture that you can use to later be creative and do modeling. Like you can see there's like a variety of shapes, and with the same technique as I showed before, you have there the how you call it, the normal map, and there's metalness and roughness. You just create them yourself. Just get textures, style them, do whatever you have learned. Make sure that the albedo texture, which is there doesn't really have any lighting, because usually lighting happens with the normal map when a light happens to it. So just create anything you want, like an atlas there. And the idea is that when you start modeling, and you create your models using the UVs for this atlas you made. You just have to be creative. Like you just create a lot of things that you will feel that you will be useful for you to model. Can be like a bunch of them, and then just for example here, I made this table using the atlas. This other table, I made a window. I made something like to sit at, like a chair or sofa. This was all done using the atlas. You can see the window has like a lot of things for whatever. So in the end, you can create like this room was created using this technique. Like it was really quick. I made it in a couple of hours, just showing that you can just create an atlas and do a lot of furniture with this atlas very quickly. This technique is called like atlas-based modeling. You first create the atlas and then create the objects that use the atlas. As far as I know, I think Overwatch is one of the games that use this modeling technique, but it's very common in the industry to use this modeling technique. So let's go back to the one used for the TPS demo. This is called geometry-based modeling. The idea is that you don't really care about just texturing much all the details. You just model everything. They don't care if you have screws. You just put like a polygon where there is a screw. There is a everything. You just like normally when you are modeling this thing in here could be a texture. This could be a texture. You just don't care with the technique. Everything is geometry. Don't do any kind of detail and texture. Just make really complex geometry. Why? Because nowadays with GPUs, it doesn't really matter. I mean, you can make really complex geometry and the GPU is going to handle it. Unless you really willfully put like millions of polygons into some object or something like that, modern GPUs, you just make something very complicated. They won't really mind. The transform of the vertices is very fast nowadays. So what you do is, after you created the geometry, your materials are something called tree-planar. Have you heard of tree-planar mapping before? Tree-planar mapping is something, it's also called auto-texturing. I will show you, like, with the texture we have just created, we will do tree-planar mapping.
There was a question on the chat.
Yeah.
Why is one using alpha build of Godot 3.1?
Oh, I didn't update it, sorry. My computer, no, I broke this computer and forgot to update Godot. So let me show you this very quickly. I will create a 3D scene. Well, we have this scene before, but let's make a new one. And I will create a mesh instance. We can use actually CSG, would be very nice. Like, we'll use a CSG combiner. And then let's put like a box, and then let's put like a sphere, and then we can subtract the sphere to the box like this. Where is the operation? I forgot how my own thing works. So the operation was here. Do you guys remember where the here, subtraction, there you go. So the sphere should be subtracted from the box, but was it this how it worked? I don't remember. I should read the documentation clearly. Or was it this one? Okay, yeah, that makes a bit more sense. Okay, now, yeah, it's the second that works on the so it should be the opposite order now, I think. Well, I don't know, something like that. I will just add a light. So this looks a bit better. Now, this was subtraction, or this was subtraction. Oh, okay, there we go. Imagine we have modeled this object. So texturing this requires to just UV map, put everything in a texture, then UV map the texture, create a material, special material for this that uses the texture that you are painting for this. So auto texturing is the same as tree-planar mapping. I will show you how it goes very cool. I will create a material, new spatial material. Let's make it for now. Albedo, we'll use this albedo floor light here. There we go. I have this texture here. This is using the UV of the And this one also will put the same material. So let's copy. What? Paste. Okay, it's using the same. It's using the UVs now that come with it, but it doesn't like. Looks kind of shitty. So it's all deformed here. It's not nice. So auto texture is something you can do, which is you set here in UV tree planner, and then look, it's all pretty. What it does is just create UV texture. It just creates. It doesn't use UV mapping. It just is like it samples in 3 different axes the texture, and depending on like the normal of the object, it blends between them. So you can do something really quick, and you get texturing. Like for example, if I were to rotate this, you would see something very disturbing. Like it's like, oh, because it's in local coordinates. Okay, let's do it in. Where is this? I don't remember. I think it's here. Flags. World tree planner here. Now it's in world coordinates. So if I rotate this, you can see now what it does. This automatically creates like UV coordinates for your object just by. But you can see that actually what it does is just blending with the other axis. It just samples like once per axis and then blends depending on the direction the object is. So this is called auto texturing. For world coordinates, it's easier to use world tree planner. For local objects, it's easier to use local tree planner. But this makes sure that you just model an object and then you just put the material and it automatically has like texture. You don't really need to do UV mapping or complex things. It's a very quickly way to texture objects. So combining the texture I showed you before, which is just model everything as geometry, don't do detail as texture, with this technique which is called tree planner, then you can have a lot of pre-assigned material. Like for example, you can make a metal, you can make wood, you can make like a lot of different materials. And when you make geometry, all you have to do is just assign those materials to the different like slots in the object, and you really quickly have really complex geometry with texture without having to unwrap the UVs or everything. Thanks to this, we were able to make the TPS demo so quickly. It's just a workflow that works really well. So going back to the presentation, it doesn't use the window. Okay. So this is how it looks when you do it properly. This is pretty much just there. It has a bit of texture work, but mostly it's just tree planner, and everything is just geometry. Like there, all the detail you see there, all the cables, everything is just. Let me show you a bit better. So, like this hole is model, this is model, this is model, all this detail here, and everything is super high poly. But it just doesn't matter because your GPU is going to handle it fine. Like you can see, has a lot of geometry. Well, it looks really good. I mean, you can make this very quickly because you don't have to care about texturing or UV mapping or going to Substance Painter or anything like that. The alternative will be to just use Substance Painter if you want. It's more work. Probably looks better if you take more time with Substance Painter, but it's not open source, so I can't use it for the talk. But I'm just waiting for the Blender guys to implement something similar to Substance Painter regarding to just taking a material that has like the metalness, the roughness, the albedo and everything, so you can just paint it over a surface with all together. They still haven't done that. I've heard that they're going to do it like after Blender 2.8 is out. So come on, Blender guys, we need you to save the open source or game development world. But anyway, this technique works really well. It's really easy to do. You can create a lot of very, very high detail looking geometry very quickly. So you can see here, the nice thing is the materials are really reusable. You just model and then assign materials. This is just the way, if you have seen, for example, DreamWorks or Pixar movies, they do this a lot. They have modelers that just do all the geometry with all the tiles, and they have the guys who make the materials that just make generic materials, and they drag the materials over the objects. It's the same technique. So basically, it looks really good. If you just look at it, just using geometry, it's not so much effort, and it looks really good. And Godot has JProbes, which works really well with this. So finally, level design, and we're reaching more of the end of the talk. Here, the level is built in Blender. If you have a grid, like you probably saw at first that we have a level blocking, which is like the very basic shape of the level. Once you have the gameplay working in there, you just tell your artist, okay, make it pretty. So everything is done in Blender. I will show you this instead of explaining it. It's somewhere. No. It's here, right? Actually, no, I will use it in Blender. Here we go. This is the level you have seen in the TPS demo. It's all in Blender. Okay, I don't know why it's doing this. My function. I can't switch perspective mode off because my keyboard isn't being recognized. Oh, here it is. There we go. There we go. So we go to distraction free. It doesn't work. Well, whatever. Here. Well, you can see this is the level. I will go into it, and you can see that everything has been modeled. What you can see here is, I will hide this layer here, and it will make more sense to you. Okay, this is all the geometry of the level. As you can see, this was all modeled, then materials are assigned to it. There is a lot of reuse of objects, which means that you can make something really high polygon count. But as you will be reusing a lot of objects, it's not too terrible because there's not that many unique objects in this scene. You can see this is reused, this is reused like here, all the floor is reused all around. There's a lot of reuse in this level. When you are a professional artist, you are very good at reusing things because you know that it makes your job easier. So there's a lot of reuse here. Everything was pretty much modeled, all the level is here. So you're probably wondering, like, if you want to add collision to this, how do we know where the player will collide? So this is solved by, let me show you here. Where is the level? Where is here is the level? Come on. Okay, this is where the player will walk. And this layer has all the collisions. So how does this work? You see that the geometry has suddenly become much simpler. I will toggle it in and out. So you see that look at the rails here. When you turn on the collision layer, it's just a box. This is because physics engines don't like very detailed geometry for collision. So what we do is use another layer for the collisions. And if you select one of these objects, I have no idea how to see the object here, but you should be able to see it here. No, here. The name of the object here has the string call only, which is collision only. If you add minus call only to the name of any object, this becomes a collision, and it's invisible later when imported. So you just basically model all the level and everything, then model the collisions and add minus call only to the name, and it will work. If you notice, for example, even the props here, this is the prop, but this box here is the collision. You see here call only. So you can just tell the artist make some simple collision for me where the character is going to walk and add minus call only to the name, and the artist will do it. It's really simple. So this is pretty much how you do a level design. I mean, you just give the prototype, the blocking that was used to do the prototype, you just give it to artist and you tell him, like, make it pretty. That's it. The artist will know.
Do your magic.
Yeah, you're an artist, you're supposed to know how things look pretty. I'm a programmer, I don't know about such things. So going back to the presentation. Well, you can see here, for example, it's the same, very simple collision, is very simple geometry. This is set up to wireframe, so you understand better what is the collision and what is the object. Those are the props, and the boxes are the collisions. So when you walk, it doesn't spend too much in the physics engine in there. You have to tell your artist to use final material names in their scene. They don't need to be, they can be like colors, just flat. It doesn't matter if they are flat colors. Then in the engine, you can use a planar and replace it for something nice. But if the names are not clear, then you won't find them in Godot just to replace them. So you have to be very verbose and use very final material names from the beginning. You can create likes in Blender and they will be imported to the engine. And you can import them to Godot via Collada or GLTF2. Still not supporting FPX because of the license. They have a proprietary license. It makes it impossible to use with free software. But the guys from Asim have reverse engineered the format, so we're working on making it work anyway, eventually. So let me show you what happens now. I will show you how the level is imported. And demo level, where is the demo? This is the Collada file without any modifications. I'm opening it now here. As you can see, this is the Collada file. This is as it comes. The only difference is that the materials have been assigned. You can see here in level, well, they are somewhere materials. Well, here's all the materials. They were created and assigned later. Once you import it, you just put all the materials manually, and it will look like this, pretty much. As you can see, it has a skybox that you don't want. So what you do is you create a new scene here, and you instantiate that level. Here you see that I have my scene with the demo level in here. It's the same thing, but I will create, for example, I will change the environment because I don't want a skybox, because this is like an exterior. So I will edit it and background, custom color, just black, just give me everything black, I don't care, like here. Since I don't see anything, I will set these two unshaded here. So to do the lighting is really easy in Godot. You just use something called JPro. I will show you. It's just this node is like a grid. All you really have to do is ensure that it covers the whole area. You can put many of them. I just put the JPro here. Here, it just pretty much covers the whole level. So once you have it covering everything, I will disable the here you can't see anything. I will also disable the grid origin. I will disable the gizmos. Thanks, Joan, for this. Here is the scene as it came. This thing that is here is emission, materials with emission. You can set like emission, which is that material will emit light. Everything else doesn't have emission. So when you bake global illumination and GPro, both the materials with emission and the light will be taken in consideration. So I will show you that I will bake this. It will take a bit, but it's not too long. Not nearly as long as when you use other engines. So it's pretty nice. So we'll just let it bake. The nice thing of GPro is that it doesn't really care about the amount of geometry you have. So you can have a lot of really complex geometry. It's not going to take longer because of that, or need more performance or more texture memory. You just leave it baking like this. It will take a while. It's nice because you can just test lighting really quickly. If you move lights, the lighting will be updated in real time, which is really nice. You see it's now more than halfway there.
You could add the CPU and GPU temperature to the dialog so you can see.
Oh. I think this is using multiple threads, but I don't know. Yeah, well, it's nearly done now, so it doesn't matter. And there you have global illumination. You can see now that, yay! You can see it actually looks pretty cool. Like this is, you can see the emission materials are like adding lighting to everything around. You can change some parameters in the JPro, like propagation. If you change propagation, like more or less, you can use more energy. You can just like tweak it to whatever you want. So you see, it doesn't really take that much effort to have something that looks like nice and pretty. You have now seen all it takes to do this. Now this is the part that the gameplay happens. It's around here. And I forget that we have this cool mode for FPS, like, yay. Keep the right mouse button pressed and use WASD. So you can see that the emissive materials are actually throwing lights. It actually looks really nice. Like you can see it here too. Like everything is lit by the emission materials. It's very nice. There is some leaking through polygons because it's voxel based, but in general it doesn't really matter. You just make geometry that is wide enough so it lights won't come through. I mean, this is called like bleeding. It's common with voxel lighting techniques, but you should create your geometry like knowing that this is going to happen. So in the end, it's all you care is that it looks good.
Do you have an example of that happening in this level? Or?
Yeah, this is probably a good example here. Like this here shouldn't have get so much lighting. I think it's probably because it's in the same voxel as this, so it's getting more light than it should. It's just simple things, but it's very difficult to see actually. If you maybe go to the other side, but actually we left a space to avoid this from happening, as you can see, like from the interior. Like now we're inside the Richter, but we purposely left enough room between the. See, this is like the middle part. This is so the voxel light won't come from one light to the other. So there are not that many places where you will see this, but it's what it's used to be avoided. One thing the voxel lighting has is that it's very like low frequency, so small details for occlusion won't be visible, but you can fix this by, like, for example, going here to, let me show you, for environment, and using screen space ambient occlusion. So you can just raise intensity. I will make it affect because they have our AO maps here. See that you can use a screen space ambient occlusion to simulate maybe where are you? Just went to hell. Okay, let's go back to the level. Here. This is why I was saying you can use ambient occlusion to simulate like the higher frequency occlusion. See if I turn it on and off. This makes some things like more occluded than others. Like for example, these corners. When I turn off the occlusion, like you see, it needs more high frequency like occlusion information. So combining GI probe with screen space ambient occlusion actually makes it look really good in the end. You have screen space reflections, but this level isn't really designed to use them. You can use a tone mapper. Filmic is the most common one. Auto exposure is too much for this, but maybe I can use the glow effect. You can use it, and then everything that has light will glow. You can set a threshold like 0.5. You can set the different glow levels. Maybe screen is nicer here. I can change the intensity. Like this looks better. It's way too exaggerated, but you get idea. Let's make it a bit less. It looks nice now. So you see that it doesn't really take that much work to take something that looks good. You just need to know the right techniques for modeling and for creating it. This technique of using detail and then triplanar mapping is really good because you just focus on geometry, and if you're once you start modeling in Blender, you just get fast at it. It's all key. Once your muscle memory happens after a few weeks of struggling with it, you get really fast when modeling with Blender. So you can see that in every place that it looks really good with all these things applied. It's pretty much not that much effort to get this quality, but you don't really see many in this doing this. All this demo was like made probably like in 3 weeks. So
when you had that model open in Blender, there was like a cone geometry coming out of
yes, this was done because I wanted to simulate. You can see here. This Godot still doesn't support volumetric lighting, and also this is like probably impossible to do with volumetric lighting because of the shape. So I did a special shader here that fades on proximity. If see, when I get close, actually the standard material in Godot lets you do this proximity fading. So you see that when I get close, it disappears, so you don't really see the polygons. It looks pretty nice. This is what the cons were for, just to make this shader that disappears on proximity. Players just see the volumetric part, and when you get close, they disappear, so they don't really appear like polygons. But you see, they look here far away. You can see them; they look pretty nice. So that's what it was made for. So then you can, if you want, adjust like brightness and contrast and saturate it, like, do whatever you want, like here. Better not. There I just put some saturation, and now it's like super like colory, like trendy. Like you can really use color correction. You can, like, for example, use depth of field here. Let's put 50 meters. Too much. Too little. Here. Now you see what is really far away is going to get depth of field. Like another thing you can use that I think I use is the fog. The one that looks really good here is the Hague fog, Hague-based fogs. I think 0 and -100. Was it? Yeah, here. See, this looks really good, Hague-based fog, because whatever goes before looks like there is like something mysterious going in there. I will change the color so it's more here. Here we go. And that's pretty much, there's not a lot more than this. As you can see, it's pretty easy to create these kind of things once you know the right techniques. It's the techniques the guys in the industry don't want you to know. But yeah, that's pretty much it. So well, this concludes the presentation. I hope you have enjoyed. If you have any questions, of course, I'm here to answer anything you may probably did not understand because I'm not very clear. Yes, I thought at this point probably most of you did see the demo already, so I didn't show it, but
Run it from a release template.
oh. There we go. This is JProbe updating. There we go. You can see this is what root motion is for. It moves so like realistic because the animator bakes the motion into the animation. So the foot always like, look at it rotate. For example, oh fuck. You see when it rotates, it's like totally realistic. This is the kind of things you do with root motion. Why it's so cool. The demo still needs a lot more polishing, but for now it's as much as I could make. Oh, one more thing. You probably noticed that the sound is very reverby and everything. I will stop the demo and show you. This is another really cool thing you can do with the engine now. Let me show you. This is really cool, actually. You know that there are two different areas. This very large area that has the deck and the reactor, which is inside. This is the level for the game. There is something really cool here, which is that we'll look for it. Where is the sound? Here. There are two areas. You can use areas not only for detecting objects in Godot, but also for sound. They have a property here, which is called audio bus. Audio bus, you can override an audio bus and send it to a bus. What does this mean? There is this area here, which is outside sound. Let me turn off the effects because it's not very clear then. Here. There's this area. Can you see the shape now? Here. This is the outside area. This is the inside area for the area. I think it's a capsule. These areas send to different audio buses. Here you have two different reverbs with different settings. So when you have sounds in the outer area, there is a much larger reverb happening. And when sounds are produced on some other area, they send to the reactor bus, which has a smaller reverb. Like, for example, you can see here. This has a room size of 98. This is 74, so the reverb is different. Well, I can't show you right now how it works, but the idea is that you can have different areas sending to different reverbs. For example, if you had an area that was underwater, you can send it to a bus that has a low pass filter, so everything is muffled. So the audio system, the position audio system in Godot is really cool also. This demo showcases it, but it's not really clear. I didn't add it to the presentation due to lack of time. So yeah, any more questions?
Yeah. Question, you showed this Atlas, no, not Atlas. When you block the demo game.
Yeah.
I didn't understand why you do it like this. Why don't you just make a chair without textures and so?
Oh, no. The chair demo was just a modeling technique. I didn't use it for this demo. It just was when I have the chair on the living room. This is just a modeling technique that you can use. It's a different one than the one that was used for this demo.
But why would you do it? What is the benefit from it?
No, I just show it because it's a different way. The talk is about making open source games. So I added this different technique you can use just in case you may want to use it because modeling something too complex. If you're going to target mobile, probably using this technique of doing really complex geometry is not going to work, but the other one will work fine because it's very low polygon.
So the main reason to use Atlas-based modeling is to reduce polygon count?
Yeah, it depends on the style probably, but it really depends on what you like, what your style you like. It actually is a pretty low polygon technique, so you can use it for mobile. It works pretty well. The other one is not really for mobile. It works really nice for desktop. So yeah, that's pretty much it. Well, no more questions then. Well, thanks everyone. Oh. Oh, sorry.
I just wanted to ask, it's a bit of a question and a bit of sharing personal idea, that's why I wanted to ask it at the end. It's just a quick remark about the choice of the robots and that is avoiding the conversation between male and female issue.
Yeah.
Putting on the robot. So I just wanted to say that I noticed the whole universe and the whole discourse saying, well, the artist can do anything, I'm only the programmer.
Yeah.
It's something that I put in question.
Yeah.
I think, and I know that in the Godot community you value that a lot, dialogue in between artists and programmers.
Yeah.
That's I think it's a big, it's a really big asset. And I just wanted to share with you that not being a programmer, being an artist, I will try in the coming years to work about how to develop through workshops and engaging more persons, more feminist-centered scenarios involving collaboration, involving not only changing the character from the robot to a unicorn, but really trying to see if you can put some other principles of interaction with it and work with Godot on that. And if anyone has any interest and maybe more knowledge, I'll be happy to take over the discussion that I have with you.
That'll be nice.
Already working on.
Thanks. But it's okay, thank you.
Clap again, you can clap.
Oh.
half an hour and then we close up shop for today.
Like that?
And if some are leaving early already, please try to be here at 9 tomorrow because we'll start fast. So if you're late, you will miss the first talk tomorrow.
Okay, so I'm going to present a bit workshop about creating reusable components. Is the microphone well?
Microphone is for the stream.
Yeah, but do they hear me well like that or? Yeah. Okay. Just wondering. Okay, let's wait a bit. So when I see some example projects on GitHub and also browse games and so on, I have seen many people do some pretty weird things and not create truly reusable and modular code. And also I have made a few games lately which I think were good examples of how reusable components can be made. So I will make a few examples first and then talk a bit. So for the first example, we want to make a settings page. And for some additional speed, I already have it all made in Godot, so I can jump right in. So on this page we have some random settings which I won't discuss much, and we also have a key bindings menu. And the key bindings menu is a bit weird because we have to have a script for it, right? And also we might want to reuse this script. So let's first make it the stupid way, and then I will show the smarter way. It's not very stupid actually. So the first way would be just to go to the settings menu and add a script which does everything. It's not a big deal, so let's just make a script. And maybe I should copy it. Should I? Let's copy it. So I will just go through it step by step because it's easier that way. So first I go over all the children in the child nodes in the keys menu and find all these buttons. And I just connect the toggled signal so that I know when to rebind an action. Afterwards, I just have the rebind function, which listens to that, and just starts listening for the action, and makes sure that no other buttons are toggled, because that would be pretty bad. For example, rebinding multiple settings at the same time. And finally, if I'm listening for some action, I just and receive an input event, I just update the button and update the input mapping, and make sure that I stop listening. So this is pretty much the code, which can be written in maybe 10 minutes. So I'm going to run it, just so you can... Oh, that's F7, sorry. So, just to see that it actually works, we can rebind things, so it's good. So, that's good, but it has a problem. We can't reuse any of this. So, for example, if I want to add a pause menu, which also has key bindings, I cannot reuse it there. And also the script is actually pretty complicated. I mean, Well, because it's on the settings node. So if I want to reuse it, I can probably move it to the keys menu, and then I can reuse it, and it's fine. But I still have repetition. I still have these actions which are repeated, and as you can see, it's actually repeated the same everywhere. So we always have a label, a button, and an HBox container. So an even nicer thing is that we can do is just separate this as a scene. Godot makes it very easy. What? Sorry. Should have thought of that. Okay. We're fine now. So I can save this as a scene, and let's call it an action or key binding maybe. And I will remove the second one and duplicate the first. And now I cannot control the text. So I have to add a script which does this, and this script will be a tool script, so we can see things in the editor, but currently I'm going to do it without it being a tool script because it's faster. So no. Okay, let me just copy the very basics. So that's the usual way in through which I set up a property. I have it with a setGet so that I can update it and maybe later make it a tool script. Then in ready, I just call the setter because it uses some of the child nodes and I have to be inside the tree for that. Well, not exactly, but the setter is basically called before the child nodes are even instanced. So I have to call it again after that. And then I just fix the label text and then go through the event list to find the text for the button. And that's pretty much it. And now I made a mistake. This should have been on the scene. So let me just go there and put it correctly. Okay. So now I have the script on both nodes. And if I run the scene, nothing in space. That's not good. I forgot to set the variable. Oh. Jump. And boost. So now I have a proper key binding menu, and I actually removed some of the repetition, but we can do better. We can actually get the whole binding and rebinding things out of the settings menu and into the scene. So for that, I will first connect a signal, the toggle signal, maybe. Oh, wait, actually I don't need a signal. I now remembered. Sorry. So basically, when we receive an input event, we can check if the event is a put event key, and then we can check if the button is pressed, because if it isn't pressed, we are not rebinding it. And in this case, I'm just going into the other script and copying from there. We basically want to do all of this. So let's see. First, we have to set the input as handled, so if somebody presses down, it doesn't go to the lower button, because that wouldn't be good. Then we clear the events for the action and put the new event there. Then we update the button text, and we also make sure it is not pressed, because otherwise the next event will also pass through here. And finally, this is not needed. So now, actually, we removed one big script and replaced it with some scenes and a smaller script. So success. And also there are some other improvements. For example, the addition of this for loop, which takes the action list and finds the action which is currently bound, actually means that we no longer hard code the initial buttons into the menu, because we have to find them anyway. And also we can do even better. We don't have to duplicate this line. We can actually just call the other function so that it updates the button. It's a bit weird, but works. So now, if I run it, we can see that we have a new menu which works even better. But so far, while making things more reusable, there is a slight issue. I noticed that we lost some functionality. Basically, I can now click both buttons and then bind something to both. And that's not good. But it's pretty easy to fix because Godot has something called button groups. So I can just make a new button group for all key bindings. That's it. I think. Oh, whoops, wrong scene. And it should work. No, I didn't test it. I'm sorry. So, let's see what we can do actually, because we're coding live, right? Okay, so maybe we hit some bug. Anyway, this should work, but if it doesn't, we can either use the button group to get other buttons and disable them, or maybe do something like emitting a signal from the key binding and catching it in the main scene. So it's not that bad. And also, if we want to reuse the key bindings menu in the pause scene, now we don't have to include this title and separator, because maybe the pause menu looks different and it wouldn't fit there. So that's another plus. So that will be it for this example. There will be another example, but I would like to ask if there are any questions so far. Yes?
Not a question, but I think the button group will work if you save it out as a resource and use that resource instead. I think
oh wow, it's local to C. Yeah. Okay, so if I disable local to C, it should work. Yes. So now maybe it works. Yes, okay, thanks. Didn't knew that it instances local to scene by default. Okay.
Write documentation for.
Someone should write the documentation, yes. So that I don't make stupid mistakes in production. Okay, other questions? Okay. So that's for the first example, and we will return to it at some point, so let's leave it open. And the second example is a player scene. Where's that? Okay, here is it. So we have this player which has a nice fire-looking particles effect. It's not very good because I didn't put too much time in it, but it's mostly good. It actually looks so much different on my screen, but alright. feature, yeah. So basically, we want to make a script which changes the color of the particles so that we can have either different color particles or something like that. Let's say I'm prototyping a game and I just want to add differently colored particles. So I will go for 3 colors. One is this color, which is fire, and maybe some ice and water colors, so that I can have some more mechanics coming from that. So for that, I will make a script, which will be a tool script, because I actually want to see these colors in editor. And let's see how we can do it first without making it very reusable. So maybe I can copy it. So I will copy at minimum this part, because I don't want to pick the colors again. Oh yeah, I don't have the setGet. So we make a new color. So yeah, we don't make a new color actually. So if we are inside the tree, so it's not the first call of the setter. Sorry. What we do is just get the particles node and set its modulate to the color from the colors array. And we shouldn't forget to call it in ready. And actually, does it work currently? Okay, it already works. So it's pretty simple. And now I have a player which can change colors, and that's cool. I like it. So maybe after making this elemental colors player, I want to make an enemy which also has elemental colors. So I have something which I can reuse in this case. And one idea is to just make this script the base script and then instance it in both the player scene. Inherit from it from both the player script and the enemy script. That would be decent, but there is a slight problem with it. For example, it extends kinematic body 2D. It actually doesn't use anything from it, so we can actually make it extend from node to 2D. It won't work, but we can do it. So that's a waste. And it means that, for example, we cannot have an enemy which is a rigid body. So maybe we want an enemy which falls and bounces. But we cannot do this because it won't be a rigid body. So that's maybe not the best way to do it. And if we look carefully at the script, we can see that the only thing we are actually changing is the particles 2D. So we can actually put the whole script on the particles 2D node. So let's do this. I will just leave the defaults there. And I will just copy my whole script. Change the extents and fix this thing. And now I can remove the script from the player for the moment. So now I can also switch colors, and that's not all. I'm gaining the ability to use, for example, a projectile which is not a kinematic body, but for example, a rigid body, or an enemy which doesn't have anything to do with kinematic or rigid bodies. Also, I gained the ability to actually have multiple particles. So I can maybe make another particles and just change the material. So maybe they go faster up and have a darker color, but yeah, you have to make this unique as well. I already messed up this once, so I don't do it twice. So that would be my smoke-like particles, if it works. So no damping, and we can see them because they're additively blended, and we made black material. So let's just clear this. Ooh, that's some smoke. Okay, now we have smoke, and we can actually use the same script for both and even change their colors at once. And we also gain the ability to have, for example, an enemy which combines all three elements and somehow has all the particles inside it without having to make it in three separate parts. So by just moving the script, we made it more reusable. So questions, maybe, so far?
Not a question, but to reword, maybe, make sure I fully understand. You advocate for, whenever possible, move the scripts further down the tree and not always on the root node and code everything.
Yeah, that's one of the things. The other is to just pick the smallest part and make it modular, instead of making one big script which does everything, because big scripts that do everything are hard to understand and are hard to modify to fit other use cases later. And that way you can actually save time later on, for example, by just you can even, for example, take this key binding thing and, for example, put it in some instructions inside the tutorial so people can key bind from there, and so on. You gain more possibilities just by making it small and reusable.
And if you want to modify the style, just modify the one chain.
Yeah. When you have something specific, for example, let's say that you make this, and then you decide that you want to have 3 types of enemies for each element. You either have to add a script here which exports the property, or you can actually make them separate scenes. So you have a fire enemy, ice enemy, and a water enemy scene. And that's not a problem because it's just 3. And you can also that way add them add some specific behavior to each. So for example, the fire enemy is very aggressive and goes to you directly, while the others are more cold. So I had some notes for the ending, so I will just switch to them because I honestly forget them very fast. So basically I will just read them. You can't, so that's good. So at first, making parts of the game reusable makes it more modular and thus more maintainable. And fixing bugs in such reusable and maintainable code is actually easier because you have less code to keep in mind. And also doing reusable components from the start is useful even when prototyping, because you can get ideas from there and also reuse them in multiple places in the prototype. And making a component reusable from a non-reusable one is also not very hard in Godot, because you can just copy most of the script and change a few things here and there. And a few notes about how to select what to reuse, because not everything is a good candidate for making something reusable. So for example, if you have a player scene, you don't want, for example, the move, jump, and whatever other behavior you have to be reusable, because maybe only the player needs them. So if you want to have it in multiple places with almost no differences, like the key bindings, reuse for sure. And that way you can actually get some flexibility out of it. And also, if you have some repetitive structure and you don't reuse it, it means that you're going to have trouble changing it later on if you want to change it. So for example, if what? I don't want this. So for example, in the key bindings menu, if I wanted to make the key binding text, for example, glow a bit when the binding is clicked, so players can check their keyboards fast or something, I can just add an animation player, make the animation glow, for example, and just okay, glow would be a bit weird, but we can do that. So maybe just have a shadow. Can we do that? And okay, so at first we are going to bind those outlines, and we can just make them, for example, to 1, so it glows a bit visually. It won't look good, but concessions have to be made. But why 1? So, and then I can just go into the script and maybe check if event is action pressed, my action, just get the animation player and play glow. And we can actually test it. And I don't have to make it for every button. Yeah, and okay, so let me just press A. Does it work? That's weird. It should work. But as I said, it should be easier to fix bugs in this, so maybe we can fix it. No, I don't want to. Okay, Z. Anything to output? Yes. So it actually plays the animation, but we cannot see it because it's small or something. So maybe I should just make it like 10, and it looks terrible. Can we do that? Actually, I should play it in the editor. Wow. Okay, that's fun. Why not? What can go wrong? Oh, okay. What can go wrong? Sorry, wrong scene. So I press Z. Okay. So second consideration is if it's going to be used in multiple places, but there can be differences. For example, the keys menu. I can use it in the pause menu, but maybe it won't have the separator and the key bindings title. In this case, maybe a base script or a base scene would be more useful, so I can probably just make the key binding script and not the whole scene reusable. Also, for example, if I want to reuse this title and separator thing, I can just make a scene out of this, and then I can instance it for the keys and the graphics, but that's probably an overkill. And finally, if we're going to use it just in a few places with very large differences, or some large differences, it's probably better not to reuse it so far. So for example, if I have a player and something else, for example an enemy, which have similar code, maybe I shouldn't merge them with a base script, because at some point I will have to add many things to this base script, which will just bloat it. And it's only a player and an enemy, nothing else. But maybe if I have many enemies which are very similar, I should merge them. And also, for example, these key binding and graphics menus, they're pretty nice, and I can make a scene out of that. But it's used only in 2 places. I don't gain anything that way. If I use it in many menus, then alright. And for example, as a last example maybe, this lights option, it is probably a good idea to reuse it, but just making this whole thing scene, calling it an option, it's counterproductive, because at some point I'm going to get, for example, checkbox options, or maybe some option where you type a number. So maybe there should be just a base script which or a singleton which just saves and loads settings, and then some other scripts which are for the different kinds of settings, or maybe for the whole settings menu. So that was it from me, and maybe last question. Yes.
I'm not against reusable code.
Yes.
Components, but sometimes I've seen code that has really many nodes.
Yeah.
And there was this debate on the state machine pattern.
Yeah.
That suddenly can explode because you get a tree with many nodes.
Yeah.
And then getting overview of the behavior is really hard.
Mm-hmm.
So it's you know, we have to actually visit a lot of nodes to get actually the whole picture.
Yeah, I get it.
So maybe sometimes it's like, I mean, having reusable code is great, but we shouldn't go to the extremes as well.
So the comment was about the state machine pattern, fin state machine pattern. When made with nodes, you actually have so many nodes that you probably lose the context about the behavior. So maybe we shouldn't go too far with reusable code. And I definitely agree with that. There are things that, like game logic, that probably shouldn't be made into nodes. You can reuse code without nodes. I mean, nodes are just meted for reusing code, but you can probably just make it with a script with some functions. Functions are also a way for reusing code, so everything applies to them as well. So, yeah. Any other questions, maybe? Okay. That's from
Do you need
Yes, so we are closing for today. Thanks for attending this first day of GodotCon, and see you tomorrow or tonight for those who are not on the live stream.